Okay, so now that we have our Boolean expression, let me write it again here. Spoon equals B naught I naught C naught, B naught I C, or B I naught C naught. We can make a circuit diagram. So the circuit diagram, we have these all ANDed together, all going into one OR. So the output of each of these products is then all being ORed together, hence the sum of product form. So this is what it looks like in a circuit diagram. So there's our output S. The input to this first one is a B naught, so we got an inverter gate there. There's our B, I, C naught. We have then a B naught, I, C, and a B, I naught, C naught. So there's our circuit diagram. Cool. Now we could have also drawn the circuit diagram for the POS form, which would look something like 5 OR gates all going into one big 5 input AND gate. And each of these would have had 3 inputs. A little more yucky to draw in this case. So here's a nice SOP form of the circuit diagram. Okay, now another way we could represent this lovely little expression is with a timing diagram. So with a timing diagram, again, we're going to be showing all of the inputs, bacon, ice cream, and chocolate syrup, and the output S. And here I'm going to have this changing values. In a timing diagram, what you're seeing is high and low values. So when it's low, that means the value is a 0. When it's high, that means the value is a 1. And each of these can change at different times. So let's say I does this kind of thing. Maybe it stays high here and goes low again, and then it goes high again. You can have them change at any time you'd like. Maybe then chocolate starts high and goes low, and whenever it feels like it decides to go high again and low, or stay high, go low. Great. All right, so this is just showing as time marches along, as time is going to the right here. Really, writing up here is terrible. As time goes to the right, all these values can be changing. And every time a value changes, you have to evaluate what the new output is going to be. So remember our expression again. We have the sum is equal to B naught I C naught, or B naught I C, or B I naught C naught. So this is basically saying when B is a 0, I is a 1, and C is a 0. When B is a 0, I is a 1, and C is a 1. And when B is a 1, I is a 0, and C is a 0. The sum is going to be a 1. Otherwise, it's going to be 0. So anytime any of the inputs change, you have to reevaluate the sum. All right, so here we have the first change. So the sum at this case, we have a B is 0, an I is 0, and a C is 1. Is that going to give us a 1 or a 0? That's going to give us a 0, because that's not one of our 1 choices that are listed down here. All right, now we look to the next change. What comes right before that is B is 0, I is 0, C is 0. That's also going to give us a 0. The next change happens here. B is 1, I is 0, C is 0. So look at that. That's this case. We get a 1, so our sum is going to go up. Now we look here. We have a 0, 1, 0. A 0, 1, 0 is this case, so this stays high. Now we have a 1, 0, 0. Again, that's going to stay high. Now we have a 0, 0, 0. That's going to go low. Now we have a 1, 1, 1. That's going to stay low. And we have a 0, 0, 1. That's going to stay low. And a 0, 0, 0. It's going to stay low. So our output basically, if I can draw this more smoothly now, how about in green? Okay, blue. Nope. That didn't work. Don't know how that happened. Sorry about that. So it's a low, then high for that amount of time, and then low again for the rest of the time. Okay, so this is called a timing diagram. And in this case, our timing diagram does not fully describe the circuit because it doesn't show us all possible inputs of all possible combinations of the inputs. We don't have all different 8 values. So this is not a timing diagram that could give us all the information we need to know about the circuit. I just wanted to show you through this timing diagram how you go and evaluate them. Okay, so now we have represented our circuit in multiple different forms. We've done a truth table, a Boolean expression, circuit diagram, and a timing diagram. Now, how would you actually go ahead and make this, say, in a vending machine? Maybe you would like to have these 3 inputs, bacon, ice cream, and chocolate syrup in your vending machine, and you push the combination of the inputs, and you only want it to give an output in this specific case that we've described here. So how do you actually create that circuit in an actual physical circuit? Well, once again, we still need to do some modeling, and that's where VHDL comes in. So that will be on the next lecture.